Myelin is a lipid-based or a fatty substance that covers the axons of neurons, right? So this transmitting line right here, which is the axon. You can think of myelin like a rubber coating that comes on a lot of electrical cords. Well, it should come on every electrical cord. That rubber coating is there to prevent the electricity from running through those wires and arcing away from the wires and then fizzling out into space. The insulation on an electric cord, it ensures that the electricity from the wall in your house is safely transmitted to whatever electrical device that you want to plug in. That's what it does. In the same way, the myelin or fatty insulation on axons, it also ensures that an action potential is capable of traveling the long distance of an axon. The cell membrane of an axon of any neuron can be given a more specific name of axolemma. Remember, we had sarcolemma for muscle, now we have axolemma. Like any part of the cell membrane, there are proteins embedded in the axolemma, and they're voltage gated and leak gated, and throw in a sodium potassium pump every once in a while. What is not in the axolemma of the axons are ligand gated channels. So we have leak and voltage gated. I mean, why would we need channels that connect with neurotransmitters? We don't need them on an axon. Right? Those would be in the cell body because an axon is a site of propagation. It's not the original site of depolarization from neurotransmitters. In the central nervous system, the brain and the spinal cord, that's the central nervous system, the neuroglial cells that make myelin are called oligodendrocytes. Myelin, or a myelinated neuron in the nervous system, experiences injury or damage to the myelin cover on the axon. First of all, little microglia come in and clean up the debris. That's what they always do. If there's any damage in the spine or the brain, microglia are like the first on the scene, and they clean up all of the debris. As they do this, they secrete these factors or proteins, basically. These factors cause the maturation of pre-oligodendrocytes to mature to full oligodendrocytes. And then the mature oligodendrocyte, it then attaches to the axon or axons, right? Because look, each foot here can attach to more than one myelin sheath. So it attaches to a few myelin sheaths, and each of their many processes, they make the individual myelin sheath. So this picture up here on the left is as if we were to cut, oh, not there, as if we were to cut the myelin right there and take a look at it. The blue is the axon itself, and this green is the myelin sheath. And the yellow is actually the podocyte, or the process of the oligodendrocyte. In the peripheral nervous system, Schwann cells are the myelin-making cells. And these cells, they wrap around the axon a little bit differently than the oligodendrocytes of the central nervous system. So whereas one oligodendrocyte could form many myelin sheaths around numerous axons, each Schwann cell creates one of those myelin sheaths. When an axon of a neuron in a nerve, such as the ulnar nerve or your sciatic nerve, when an axon becomes damaged, the first step is still the same. The microglia come in and they clean up the debris. And you can see that happening right here. That's a phagocyte cleaning up the debris. In the peripheral nervous system, macrophages do the cleanup, not microglia. And the Schwann cells, what they do is they detach from the injury site. They're like, I'm out. I'm not going to be there while it's damaged. These repair cells, these Schwann cells, what they do is they start to form a neural tube that starts to regenerate the axon and connect with the other part of the axon. So this regenerating tube allows the axon to grow. And once the axon has fully regenerated in the injury site, those Schwann cells, what they do is they start to make the individual sheaths. This picture over here, this is the axon. And what you can see is that this is the nucleus of a Schwann cell. And you can see that what this does is the Schwann cell starts here, and then it just wraps itself around the axon, which was a little bit different to that oligodendrocyte that puts its foot around the axon and then wraps the myelin around that.